Today, the topic of discussion is on basic concept of strength of material, that is Module 1, Part 8, PCME 403. Myself, Dr. Suman Das, HOD, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. In this video, I will discuss principal stresses, principal plane, Mohr cycle, and their graphical representation. Now, construction of Mohr cycle. So, convention for drawing. So, tau xy, that is clockwise, so considered as a positive, on a face resides above this sigma axis, and tau xy, that is anti-clockwise, that is also negative, on a face reside below sigma axis. Tensile stresses will be positive and plotted right on the origin. Compressive stresses will be negative and that will be plotted left to the origin. So when we plot that xy sigma in the sigma and tau axis, so that will be discussed clearly once again. Angle theta on a real plane transfer into 2 theta on Mohr cycle plane. So in the real cases, if the angle is theta, and when we plot in the Mohr cycle plane, that angle will be doubled, that is 2 theta. We now construct Mohr cycle in the following stress condition. Number one. First one is the biaxial stress, that means there are stresses in the two axes, sigma x and sigma y only, no tau xy, that means no shear stress, only sigma x and sigma y are present. And case number two, complex state of stress, that means sigma x, sigma y, tau xy, all are present. Now, number one, that is construction of Mohr cycle for biaxial stresses, only sigma x and sigma y are known and present, no tau xy. If sigma x and sigma y both are tensile or both compressive in sign, that is sigma x and sigma will be same, and this state of stress is known as like stresses. If one is tensile and other is compressive, so sigma x and sigma y will be opposite, and the state of stress is known as unlike stress. So the construction of Mohr cycle for like stresses, that is sigma x and sigma y are same type. So step number one, that is label of the element ABCD and draw all stresses. So this is sigma x, this is sigma x, and sigma y and sigma y. Here sigma x and sigma y, this is the positive, and sigma y and sigma y, this is the negative. So this is shown in the ABCD on an rectangular or square element. Step number two, set up axis for the direct stresses as abscissa, that is in the x-axis, that is abscissa in the x-axis, the sigma is plotting in the x-axis, and shear stresses as ordinate. So this is the ordinate, so in the y-axis. So positive x-axis, that is sigma is the positive, and when sigma is negative, that will be in opposite. In the same fashion, the tau, that is in the positive direction, positive y, and minus tau, that means in the negative y. Step number three, using sign convention and some suitable scale, plot the stresses on two adjacent faces. So that is AB and BC. So this is AB and BC on the graph. Let OL and OM equal to sigma x and sigma y. So OL, this is OL, and this is OM, that is sigma OX and OL and OM. OL and OM equal to sigma x and sigma y. OL, this is OL, that is sigma x, and this is OM, that is sigma y. Representing on the axis O sigma. So this is O and sigma. So this is the sigma axis, ordinate. Step number four, bisect ML. So this is M. So bisect ML, M and L at C. So the C as a center. So we'll just get the center, and CL or CM as a radius. So CL, CL and CM as a radius. So draw a circle. So just by first of all we find out the center of the circle, and when you find out the center of the circle, and this should be the radius of the circle, that means that circle will touch the, that means M and is the L. After finding out this center of the circle, so CL or CM should be the radius of the circle. So draw a circle that is the Mohr cycle, that represent the Mohr cycle. That's why it is written as draw a circle. It is the Mohr cycle. So the Mohr cycle is now drawn. Step number 5, that is at the center C, a line CP at center C, this is center C, and line CP, then the CP at an angle 2 theta. So already I mentioned in my um, early discussion that, so the theta in the problem, what is the value of theta? So that will be doubled when we represent the theta in the Mohr cycle. So that theta should be theta or phi, whatever may be, angle will be doubled in the same direction as the normal to the plane makes with the direction sigma x. So sigma x, we just plot the same direction. The point P represents the state of stress at plane ZB. So this is the point P. So that will touch angle theta to theta, that will touch the circle at a point. So that is point P. So that point P, that means here the sigma is present and tau is also present. So that is, this is the theta, and that will be represented in the double fashion, that means 2 theta. So this ZB or BZ, so that is representing the value of stresses. That means what is the value of sigma and what is the value of tau, that will be represented with the help of this point, point P. So P is representing the state of stress at plane ZB. So plane ZB, yes. That means where is the shear stress and what is the normal stress and what is the value, that with the help of that point, that will be represented. Now step number 6, circulation calculation. Draw a perpendicular PQ. So draw a perpendicular PQ. If you see the diagram, PQ, this is the PQ, and PR, this is the PR, this is the PR, where PQ equals to tau and PR equals to sigma. And this is tau. PQ equals to, so PQ equals to value of tau and PR equals to sigma n. PR equals to sigma n. Okay. So from this you can directly calculate what is the value of tau and what is the value of normal stress, that means sigma n. So this is the value. Just draw a perpendicular on that. Now OC can be directly calculated, that is sigma x plus sigma y by 2, MC equals to CL equals to CP, that is sigma x minus sigma y by 2, PR equals to sigma n. From the diagram, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta, and PR equals to tau, that is CP sin 2 theta. So you can easily calculate the value of PR, that is sigma x minus sigma y by 2 into sin 2 theta. So in this way you can plot all the stresses and in the help of the Mohr cycle, and you can easily calculate this value. Okay. So thank you very much.